This is going to be the final topic of Python, and here I'll be discussing debugging and profiling. And debugging is something that there's no theory or concepts as such. I'll have to show you how debugging works. And for that, I'll have to take you to the code directly. And this is the same code that we executed. Now we want to debug this particular code if something goes wrong. Again, I'm not showing you by breaking something, I'm just showing you the steps, and you can follow the same steps to do debugging of your code also if something goes wrong. The most basic form of debugging is print method or print function. Using the print function, you can do debugging also. Just put print function whenever there is any problem and see what the problem is. And I have done that across all the errors that you have got so far. But let's say there is a very complex code and you have to do some debugging, and writing print statement each and every places might not be practical. And also if it's a production code, it's not advisable to write print statement, because if you forget to remove something, remove some print statement, that might create a problem. So better to use a debug, and for debugging it's always better to use an IDE. I'm using PyCharm. If you are using VS Code, that is also fine, but I'll show you debugging using PyCharm. Now, whenever you execute this code, there are two ways that you can do it. One is click here, it will run this particular code, and there's one more, if you see, debug the same code. So if you see this bug here, we can click, if I click on this, it will debug this entire code. Also, if I do a right click, there are two options to execute the code. One is run, and then the other one is debug. But before doing the debug, I have to see where do you want to start the debugging with. So what will I do? I will start the debugging maybe here. So if you go to the number, you will see this red. If you click, it means that the debugging would start here. This is the first breakpoint, and maybe this is the second breakpoint for this particular code. And I want to debug this entire from this block to this block, and also I want to debug from here till here. That's what I want to do. But before that, let me just comment all these, because otherwise I'll be in loop continuously. All right, so let us go ahead and do the debug. I have put two breakpoints. Of course, you can put multiple breakpoints here. This is the one, then maybe this one again. You want to see that, okay, go to the next breakpoint and see what is happening here. So after setting the breakpoint, of course, you'll have to click on this particular debug. Make sure that you have enough screen place in the bottom, because you'll see the debugging output here. So let's click this, and here you'll see this thread and variables, and then you have console, and here you can see what is happening. Which place we are at? We are at the place where actually the program begins. And here if you see, there are multiple buttons. This is the stop button, this is the pause and resume button, then this is the step over, step into the go to the next one, so on and so forth. So let's get into the next step. So I'll click on this. So as you can see, it has gone to the next code, and then if I click again, it has gone to the next one. So now here again I am into thread and variables, and go to the next one. What it is doing, it is showing the for I in range, so on and so. So if I click next, it will show you the value of I. So if you see, the value of I is 1, the number of files is 2, and the threads is empty. So it is showing you what's the current value of all the variables. Now let's click next. It is showing the value of file name here also. If you see, the value of file name is actually this, and then the print statement, then the format I, everything is being shown here one after the other. Now in this particular place, it is calling the function, and then if I click next and then start, it would go to the function, because this is where it has been started. And we have passed the variable, we have passed an argument rather, the file name, and this is the value of that. And in the console, you see that it is currently executing thread 1, which has been shown. Now if I go to thread and variables, it says that it has gone with the variable file name, and the value is this, and the type is string. So you can keep on watching this particular place also, wherein it will show you the values. Now if I click next, of course it will go to the next line. It will tell you IP file, which is basically an object with the file. Click next, it will print the lines, and here it is showing you all the lines actually. Of course you can expand it also, but that is not needed, and you can see the value here also. And if you click here, it will show you all the values which might not be needed. And let's keep on clicking next. So we have one more file. Now all the other codes have not been executed because I have commented all those. Let's go to next, and then it has gone to the for statement because one file is done. So now it is going to the second file. As you can see, the value of I is 2 here. And now if I keep on clicking next, it will go to the function and will show me all the values here that has happened. And it is a very useful tool if you have a pretty huge program. So right now the program is small, that's why it is not making too much of sense maybe. But let's say you have tens of functions and you might want to see where the error is and why the error is. So let's say you do not want put breakpoint in all of them, but put breakpoint in only one of the functions and remove the other. So what you can do, you can get inside of this function and look at what are the value of the variables, what is happening while the code is getting executed. And you can see that here also in threads and variables. So all the variables would be shown, all the values of the variables would be shown, etc. So using this, you can pretty easily debug your code. And if you're done, you can stop the code debugging as we do to stop a program. So that's what debugging is. And then I want to talk about profiling also. And there are two types of profiling. One is CPU profiling and the other one is memory profiling. Now the question is, what is profiling? Profiling is used to find out the execution time and memory usage of a program. So if you do a CPU profile, if you use the module C profile, then it will tell us the execution time of each function and its sub functions, etc. Similarly, if you use memory underscore profiler, we can see the memory usage of the section of the code. Now C profile will get out of the box and you'll have to install memory profiler using pip. And I have installed both memory profiler and C profiler, so I'll delete this. Either you can use it in this particular terminal, but let me use this terminal and I'll execute the code which is multi-threading. So let me try to find out the CPU execution time. Let me profile the CPU. But before that, what will I do is that I will reduce the number of files to 1. I will execute the program also. So I'll print the record and I'll execute this. And here what will you do? We'll use Python 3 and then I'll have to mention this -m. And if you remember, I use this in py_compile also. Now what it will do, it will tell Python to run the program using the module C profile. And I'll use C profile and obviously the name of the code. And now if I execute, as you can see, it's pretty big, right? So we can see the output also because there was a print statement. There have been 519 function calls and all of them took 0.005 seconds. So this entire program took only 5 milliseconds to execute. And these are the columns. We have n calls, then we have total time, per call, cumulative time, again per call, and then file name or line number or function. Okay, so what is the n call? N call means how many times the particular function has been executed. And there are two values separated by a slash and the second value. And you will see this slash only when there is a recursive call. Of course, in our code, we have not learned what recursive is. That is not needed for data engineering also. So none of our code portion is using recursion, right? So that's why this is actually not needed. This is the total time, and this per call is total time divided by number of calls. Then we have cumulative, and cumulative is the execution time of the function and then its subfunctions also. So if you have subfunctions defined inside of these functions, if you define multiple functions, which can be done actually. The cumulative time shows for all of them. And the per call is basically cumulative time divided by the n calls. In this case, it is only one. This is again built-in function. So this is the main module that we executed, and it took 0.005. Threading.py, which we used, took only the join function rather took only 3 milliseconds. Then there was some internal calls, all were 3 milliseconds per call, and also the cumulative call. These are again internal calls, and let's see if we have calls from our functions. So the read method, which is basically used to read file, took a very less amount of time. It did not take much time at all. And if you scroll down, there's not much. All of these are internal calls, basically Python calls. The reason we are not seeing in much of the thing is because the code is very simple. But anyway, the purpose here is to show you how you can do CPU profiling. And this is how you can do it. And if your code is pretty complex, you can find out where your code is taking the most time using the CPU profiling. So you have this n calls, total time per call, cumulative call, and cumulative call is basically the function call plus the subfunction calls. In data engineering, I don't think you'll ever use subfunctions, and this is very important, the cumulative time, and it will tell you the time taken by individual steps. So this is basically the time taken for this one. Now if you add those, it will not come out to be 0.005. Remember, some of these things are happening in parallel again. So if you have pretty complex program, you can find out where it took the most time. That's what CPU profiling is. And we can do memory profiling also, and this is the command. And I have not installed memory profile. Let me go ahead and install. I'll use pip3 install and then the memory profiler. So it is done. Now if I use this, it is showing me the print. So let me do one thing. Let me remove the print statement and I'll comment that out. I don't want to print the record. I want to see the memory usage, and let me execute this. Now if you see, there's nothing being shown. Why this is the case? Because we installed memory profiler, but memory profiler needs something inside of the program also. So in the program, we'll have to import the memory profiler, and then I can use the something called @profile. So sorry, I'll have to import the profiler. So now it is fine. So I'm importing the profile. Let me save it. And now let's go ahead and execute. So as you can see, it is showing you the line number and the usage of memory. 47 is also taking 19 MB and no increment. So from 44 to 47, this did not take too much of time, too much of memory. So this particular program did not take too much of memory because see, there's no increment at all. As again, the program is very simple. So that's why you do not see any memory utilization. But if you want to see the utilization of memory, if you have multiple classes, multiple objects, you are initializing objects, etc., then you can use the memory profiler and CPU profiler. And what I would recommend you that the code that would be writing for objects and methods, the exercise that I have given, after writing the code, please go ahead and profile them for CPU and memory and see the memory utilization. Of course, we can discuss it in our live session also. So before concluding, I want to talk a little bit about the important modules or libraries that Python has. And these are mostly related to data engineering, neither web development nor microservices development. The libraries or modules that I have mentioned here, these pertain to mainly data engineering work that you and I will be doing. The first one is of course PySpark, because PySpark is something that will be used a lot. Spark is the de facto distributed computing or distributed processing for data engineering, and PySpark is used to write Spark codes in Python. Then you have Pandas. Pandas is used for data analysis, and this is mainly used by data analysts. But I have used Pandas also, and Pandas can be used by data engineering sometimes, not always. Definitely Apache Airflow, which is used to automate the entire data engineering pipeline or the flow of the data engineering pipeline. Then we have another library called Beautiful Soup. This is, again, I'm not sure whether it will be used or whether it is used a lot by data engineers, but the main purpose of this particular library is to scrape information from web pages. So this is a web page scraper, if you will. Then SQL Alchemy, which is used to connect to various databases like MySQL, Postgres, etc. Then we have individual libraries for individual databases also. For example, for MySQL, Python has PyMySQL. For Redis, Python has Redis Py. I've already told you about virtual env, which is used to create virtual environment. pseco pg2, it is used for PostgreSQL. Kafka Python, this is a very important one, which is used to send records to Kafka or receive records from Kafka, and it is mainly used with Kafka. Then you have Ray, which is a library for distributed machine learning. URL-lib is mainly for URL. Then I talked about JSON and Boto3. Boto3 is a very, very important library. It is basically Python's AWS SDK. So if you are using or if you want to use Python to work on AWS services like Kinesis, S3, etc., you will have to use Boto3. Similarly, we have Google API Core for GCP. I'm not sure whether the name of this has been changed now or not, but as of this recording, this is Google API Core. Similarly, we have Azure Core, and then we have other libraries like NumPy, Scikit-learn, PyTorch, TensorFlow, Keras. These are all for machine learning and deep learning or neural network. So let me summarize what you talked about in this particular section. I showed you various file operations. We used with statement to open a file in read mode and write mode. I also showed you open statement, which is used along with statement also, because you'll have to open the file in certain mode. Then there are modules like CSV and JSON. CSV is used to read records from CSV files or write records from two CSV files. JSON is used to serialize and deserialize JSON objects. Then I told you about multi-threading, which is mainly used to do parallel processing. The purpose of parallel processing is to reduce the execution time of your code, because you'll be using multiple threads to do the same job in parallel. So the time would be reduced. And it's not that you'll use multi-threading in each and every cases. Unless and until it is needed, you'll not use multi-threading. Then finally, I talked about debugging and profiling. Debugging is something that is explicit to the IDE. So that's why I had shown you using PyCharm. And profiling is used to find out the time spent in Python code, either by CPU or in memory. So that's all about Python. Thanks a lot for tuning in. I hope the Python course was helpful for you. See you in the next chapter.